and some of the other people you write about, that you had to be pretty intrepid to do this job.
Yeah. So in 1870, he began his first of 4 expeditions to the American West, and this was the year after the Trans-Pacific Railroad had opened up the West, and it was completely new and completely hostile because the Native Americans did not want these invaders in their country. And yet, O.C. Marsh recruited a dozen Yale students. Some of them had just graduated, some of them were still students, and they went out into the American West. They took the train the whole way, and when they got across the Missouri River, a number of them fired their guns for the first time. They got to Nebraska, where they were going to meet up with Marsh, who had gone ahead, and their train deposited them at 1 o'clock in the morning in the middle of nowhere, still 8 miles from the fort that they were going to. And before they arrived, they had heard that there was a party of hostile Indians there, so they'd strapped on their holsters and had their weapons, which they didn't know how to use, really. And then, the train pulls away and leaves them there in the middle of nowhere. And you imagine, how naive you are just getting out of college and sort of being in this incredibly strange, hostile habitat and not knowing even anything about paleontology. They thought they were going out there to shoot buffalo and to fight Indians. I mean, how naive can you get? And yet they made these great discoveries as they started to put their nose down in the dirt and dig. And the discoveries are in this room. So, this is the peculiar thing. When you come to this museum, you're so bowled over by these dinosaurs that you miss the little sideshows. And one of them is right over there. And it's a bird called Hesperornis and another bird called Ichthyornis. And they are birds with teeth. And they were a huge deal. These kids brought them back from the American West with O.C. Marsh. And then O.C. Marsh proceeded to study them for the next 10 years. And began to establish that bird-dinosaur connection pretty early on. And so that expedition, they also discovered horses. They discovered lots and lots of horse bones. And so they put them together, and they realized that they had, a complete series of the evolutionary history of the horse, from a 5-toed creature to the present modern-day hoof. And that sort of gave Darwin key evidence, and Huxley key evidence, that they needed in the 1870s to defend the idea of evolution by natural selection. Darwin actually called it, that and the toothed birds together, the best evidence that he had seen in his lifetime for evolutionary theory.
Jacques, if he's going to talk about birds with teeth, I guess we better get to dino chicken. So tell us about dino chicken. I'm sure that's not what you call it.
It works for me. One of our former students, who's now been hired as a professor here, looks at these transformations that we see in the fossil record, like from ancestor Hesperornis shared with living birds, and notes the changes that have taken place in the skull. Then he goes into the laboratory and manipulates gene expression patterns of embryos inside the egg in order to generate the actual transformations that we see take place in the fossil record. So he understands mechanistically how these things work. And one of the things you can do is take mouse epithelium, oral epithelial stuff from inside the mouth of a mouse, put it in a chicken's embryo's mouth and make it grow teeth. Two tissues have to encounter one another on the margins of the jaw in order to make a tooth. They don't meet in birds. They have no teeth. They get a bill. Put those back in there. They grow teeth, and then the face changes from that of a bird's bill to the raptors behind us. It's all governed by there being teeth present in the skull.
It's the snout to beak?
Yes.
Yeah.
And so we know that transition took place. We can see it.
Right.
But he goes into the lab and actually makes it happen.
When I was at Yale, I was in snout and beak, which is a society. So I mean, once again, when you talk about something like that, obviously the people who are doing this have never seen a horror movie, or they wouldn't do it, because it's obviously the teeth will get out and rip the veins out of people's necks. But maybe once again, pinpoint a little bit more exactly why this is significant in terms of understanding the kinds of things we're talking about.
It's how to understand these great evolutionary transitions. Look, the origin of flight. I mean, what could be a more frighteningly difficult thing? It's happened 3 times in the entire history of life, right? Insects, bats, pterosaurs, and then birds. And that line, twice he went into flight along the line that heads towards birds. First as pterosaurs, long ago, 240 million years, and then much later as birds. Once they got on their hind legs and started running around, dinosaurs freed their forelimbs to play another role in their biology, and twice took to the air. And so I think understanding these great transitions tells us a lot about, how the history of the world works.
So, Daniel, now that you're a newly minted doctor, what are you interested in now? What are you trying to figure out next?
Still sounds a little bit surreal to hear that.
Yeah.
Well, so I'm.
Well, you're surrounded by dinosaurs, and that sounds surreal.
I'm used to the dinosaur part. I'm particularly interested in the origin of modern bird biodiversity. So what I try to do in my research is use the fossil record of living birds and their dinosaurian ancestors as a lens through which to better understand the origin of modern birds and the origin of those features that today make birds unique, things like feather-assisted flight. So that was one of the main topics that I tried to broach in my PhD dissertation.
So one of the questions would be, we know that there were big things like birds before the mass extinction, but the question would be, were there also little things that maybe more closely resembled in size the birds that we have now, but those tend not to survive that well as fossil records?
Yeah, so that's a good question. Trying to understand when in the history of the Earth what we consider to be modern birds first arose has been a really difficult problem. In the fossil record, we often find that smaller-bodied organisms don't get preserved as readily as larger-bodied organisms for obvious reasons. They get broken up more easily, and they're just less likely to get turned into fossils. And for that reason, it's really taken until now for ideas about the origin of modern bird biodiversity to really start to crystallize. And just a few years ago, a study that I was a part of that took place here at the Peabody Museum set out to try to comb all of the latest Cretaceous fossil localities from the northern hemisphere in order to try to understand what sort of birds and bird-like animals were preserved in those sediments in order to shed light on what might have happened to birds and their close relatives at the Cretaceous-Paleogene mass extinction boundary 66 million years ago. And we found evidence for several archaic lineages of bird-like creatures that are just slightly outside living bird diversity, extending all the way up through the fossil record until the Cretaceous-Paleogene boundary, after which point they're never recovered in the fossil record again. So we interpreted that as evidence of birds and their kin suffering catastrophically 66 million years ago. And so the fact that today we have 10,000 living birds surrounding us is a really beautiful thing because we almost lost all of bird life completely before it ever really began to radiate into what we consider to be modern bird diversity.
So, Jacques, back to something that you said right at the beginning of this conversation. From a certain perspective, that means we have 10,000 different kinds of dinosaurs.
Only about 5,000 mammals, so
Yeah.
I don't know why we call this the age of mammals. I guess because we write the textbooks,
But also because the dinosaurs lost the nomenclature battle. We started calling them birds.
Exactly. That's a good point. We made dinosaurs go extinct by start calling them something else.
So when people talk now, we did a whole show about de-extinction. But when people talk now about de-extinction, I mean, one argument would be, well, they're not extinct. They're here. We're just calling them something else. But obviously, one reason to do a dino chicken would be to sort of, could you re-engineer birds so they got to be a little bit more like what dinosaurs used to be?
Sure.
Yeah. You think that's going to happen?
He did it with two proteins. I mean, right, the expression of two proteins. He changed the snout from a chicken beak to a dinosaur snout.
Yeah.
Two lousy proteins.
Another thing that's happening right now somewhere, Jacques, somebody is discovering a new dinosaur, right? I mean, I just feel like you pick up the Science Times.
Yeah, what is it, once a week or something now?
So are these all, in fact, dinosaurs that nobody's ever heard before, or are we back to...
Well, we are definitely at the very edge of a new renaissance with dinosaurs. It was the American interior West back in the 1870s, where all the stuff had had centuries, millennia, really, to get preserved on the surface and just lay there for Marsh and everybody to find. But most of the surface stuff has been picked up by now, and now it's all moved into China. So Asia is now equivalent to the American West in the 1870s, producing a treasure trove of new dinosaurs. And there's a big gap in the record from about 90 million to 150 million years old. It's all marine sediments here in North America. It's all from the ocean, no land. But all of that stuff is preserved perfectly in China, and they're just finding stuff all the time that's changing completely our ideas about dinosaurs. Who knew that tyrannosaurs had feathers? Well, they found one in the lake bed there in China, and there it is, covered with natal down. They put like in a down bag. And so the idea of something, 14,000 pounds or whatever, all big fuzzy chick that can bite your car in half.
I got one of the comforters from LL Bean that has the Tyrannosaurus.
It's a special deal.
It's just, it's very expensive. But, so yeah, I was reading in the New York Times today about a 242 million year old creature that swam the seas before most dinosaurs roamed the planet. They're calling it, I can't even say it, Topodendus unicus or something, which is unique, strangely toothed. And they're figuring out all kinds of stuff about its flamingo-shaped beak and its zipper of teeth and how it kind of vacuumed. It was like a hammerhead thing that vacuumed the ocean floor. I guess I'm sort of wondering, is there the analytical bandwidth to look at all this new stuff that's being found all the time?
There's so many more people now interested in dinosaurs all across the world, in no small part because it gets into the newspaper. A new bug doesn't.
Right.
So there it is.
We'll be doing a bug show very soon. All right, we're going to take a quick break here. A big hand for the panel so far.